In Monet database, if we want to use some control characters like new line, carriage return, or tab, we should use this syntax here. So in front of our string, we should place a letter E, and inside of this string, we should have a backslash and then a letter N for new line, or for example, backslash and this syntax for some Unicode character. So if I run this, we will notice that instead of these backslashes, we will get a new line, and some special Unicode character, a tab, and again a tab. Now I have two examples for tabs because this syntax, these specifiers, will work even if we don't have a letter E as a prefix. So even then it will work correctly. But what if we want to present these specifiers as literal signs? Well, in that case, we should have a syntax like this one. We should have a letter R in front of our string. And in this case, if I run this statement, I will get literal characters. Now, what control characters can be used in Monet? I will jump here to this web page, and we can see that we can use new line, carriage return, tab, backspace, forfeit, and some Unicode character. But we still have one more prefix that we can use, and that is X prefix. And this prefix is used for making blobs. So if we want to transform these hexadecimal characters into blob, we should place an X in front of them, or we can use just blob to cast this string into blob. And as we know, hexadecimal characters are numbers from 0 to 9 and letters from A to F, and we always need to have an even number of letters and numbers inside of hexadecimal string. I will now run this, and we can notice that we have created two blobs. I will now clear my screen. In Monet database, we can concatenate strings in two ways. We can use concat function. Here we have an example of concat function, and we can see that this function can only concatenate two strings. If we want to concatenate several strings, it is much easier to use concatenation operator. So if I run this, we will see the two ways how to concatenate strings in Monet database. Next, we will see how to find out what is the size of a string as a number of characters. Here I have a string with 2 characters, and I can return that number to with length function. So if I run this, I will see that my string has 2 characters. Instead of using this name for this function, we can also use other names. For example, for this function, synonyms are also char length and character length. So we can use these synonyms instead of length. Now, in Monet database, every character is encoded in UTF-8 encoding, and in this encoding, some characters occupy several bytes. For example, this symbol here will occupy 3 bytes, so this string will need 4 bytes in order to be written to memory. And in that case, we can use this function octet-len that will return number of bytes for some string. And in this case, the result will be 4. I will now clear my screen. If we have one substring inside of another string, we sometimes want to find at what position. So we can use locate function. And this locate function will search for this substring inside of this string. So when I run this, I will get the result 5, because on the 5th position here is letter E, and after that we have S, so we have ES. If we apply this third argument means not to search for ES in the first 8 letters of this string, so we will find ES here, so it will be at the position 9. We can also use this function with a different name, and that different name is char index. So instead of locate, we can use char index. We also have one more similar function, and that is position function. It has a little bit different syntax, and it will return the same result as locate with 2 arguments. We cannot use this third argument in position function. Next similar function is path index, And this function is special because it can use wildcards. It can use %sign to represent a 0 or many characters, and it can use underscore to represent only one character. So I will run this, and we will notice something different. Instead of getting the result 5, we will now get the result 6. And this is because path index will not find the position of the first letter, so it will not search for the position of letter E, but for the position of the last letter, and that would be letter S, and letter S is on the 6th position. I will now show you some examples for path index, so we can see the logic behind this function. Here I have S, and then %sign, and then C. And this will not find anything inside of this word, so the result will be 0. But if I add a %sign in front of this, then it will find the result, and that result will be number 4. Now why 4? Because it will not take account this letter C, but this. So it will search for the last letter that fit to this description. So instead of getting C on this 3rd position, we will get the C on the 4th position. If we add to this syntax one more %sign at the end, we will not change anything. We will get the same result, and that result will be 4. If we want to have a specific number of characters between two letters, then we should use underscore. So here we have C, and then some character, and then S. So it will find it here, and because S is at the 6th position, that will be our result. If we search for the whole string, and then we apply this %sign at the end, we will find this S at the end, and that will work. But if we search for the whole word, and then we have underscore at the end, in that case, we won't find anything because we are looking for this word plus some letter at the end, and there is no such letter, so we won't find anything. The result will be 0. Now, for all of these functions on this screen, it is true that they are case sensitive. So if our cases don't match, in that case we won't find nothing, so we will return 0. I will now clean my screen. Next thing that we will do, we will extract one substring from another string. For example, in this case I have this string. I will search for the position 3, and this is that position, and I will read the character on this position and after it. So if I run this, I will get this substring here. I can also use this 3rd argument to limit number of characters inside of my result. Then we will see the example that will show us what will happen if our arguments are too big. In this case, we have a string with 3 characters, and we are looking for the 5th position inside of this string. So if I run this, I will get an empty string because there is no 5th position. And then we will look at this example. Here I'm looking for the 2nd position, and after this position I'm looking for 7 characters, and because 7 is too big number to limit number of characters, because we only have this character on the 2nd position and this on the 3rd position, this will not limit anything, so we don't actually need this character. We will get the rest of a word. I will now clean my screen. Next, we will see how to change the case of our strings, and for that we have a function LCase that will transform a string to lowercase, and UCase that will transform a string to uppercase. So if I run this, we will see how this string was changed to this string. These two functions, they have synonyms, and those synonyms are lower and upper. So instead of LCase we can use lower, and instead of UCase we can use upper. We also have this special function. This function will do next. It will first remove all of these strange signs, so only letters and numbers will remain, and then letters will be transformed to uppercase. This function is used to transform strings in some more standardized presentation, so we can more easily compare different strings. Next, we will take a look at functions that allows to compare strings alphabetically. In the alphabet, we know that letter A is before letter Z. So min function will return apple because it is the first value that is before zebra, but max function will return zebra. So if I run this, this will be my result. And these two functions also has synonyms, and those synonyms are least and greatest. Next, we will take a look at ASCII functions. First, here we have ASCII function that will take the first letter in the string, and then it will return an Unicode number for this letter. So I will run this, and we can see that Unicode number for this letter is 223. Code function will do the opposite. It will take that code and it will return that character. We also have ASCII function, and this ASCII function will accept any string and it will return that string, but everything will be changed to symbols that exist in ASCII. So ASCII encoding has only a limited set of characters, so everything that is not inside of that set will be transformed to some characters from that set. For example, this sign here will be transformed to EUR. I will now clear my screen. We will now see how we can add padding to our string. For that, we can use functions left padding and right padding. So if we run this, we will get strings that have 5 characters. So this here has 5 characters, but we have 3 space signs and then we have ZZ. With right padding, we will first have ZZ and then 3 space signs. I also have these arrows here, and they are only here to show us that we have spaces, so because spaces are invisible. Now, instead of using spaces, we can use any other string. For example, we can use this string here that has 2 characters, and we can use that string for padding our main string. So we will have ZZ, and before that we can repeat this third argument, and we can do the same from the right side. Now, what if our main string is already too long, so we don't have to pad it? In this case, we have a string with 5 characters and we want to pad it up to 3 characters. Well, in this case, our string will be shortened. So the last 2 characters will be removed and we will be only left with 1, 2, 3. And this is the same for left padding and for right padding. I will now clear my screen. For string trimming, we have 3 functions. We have left trim, right trim, and we have trim that will trim spaces from the both sides. So when we use ltrim, these spaces on the left side will disappear. With right trim, spaces on the right side will disappear, and with trim, spaces on the both sides will disappear. So when we run this, we can notice that we don't have any spaces. Besides spaces, we can trim any other characters. For example, here we have characters U, and we can trim them by using this second argument. We can also trim them on the right side, and we can trim our characters from both sides. So if we run this, we will remove all of the U characters and Z characters. Then we have functions for repetition. We can use space function to repeat space, for example, 5 times. So when I run this, we will have 5 spaces here, and we also have this repeat function. This repeat function can repeat any string. So if this is the string, and if we want to repeat it 5 times, we can achieve that. I will now clear my screen. If we want to extract several characters from the start or from the end of some string, we can use left and right functions. So here they are. So we can extract first 2 characters or last 2 characters, for example. Then we can check whether our string starts or ends with some other string. For example, we can check whether this string here starts with AB and whether this string here ends with BC. So when we run this, we will get true and false. In this case, both strings have upper letters, but in this case we have lower b. So this will not be a match. So in order to solve that, we can use the third argument. And if we provide a value true for this third argument, that will make our functions case insensitive. And then both of these expressions will return true. So it doesn't matter if our letter b here is lowercase, and if this is lowercase, we will get true. So we will find this second string inside of this first string. Then if we want just to search for some string inside of some other string, we can use contains function, and this function will try to find this string inside of this string, and it will return true or false. And this function is case sensitive, so this expression here will return false. So if we run this, we will get false, but we can change this result to true if we provide this third argument, and if that argument is true, then we will have comparison that will be case insensitive, so we will get true. I will now clear my screen. Replace function is used to replace one substring with another. Here we are searching for substring repeat, and if we find it in this first argument, we will replace it with try. So instead of repeat, we will get retry. So if we run this, retry will be our result. But this function is case sensitive. So if first string has lowercase, second string, if it has uppercase, then nothing will be replaced. So this first string will be returned as a result. Next function we will talk about is insert function. This insert function is doing the same thing as a replace function. So we will search for some substring, and then we will replace it with another substring. So we will get this as a result. But how do we know what to replace? Well, for that we are using these two arguments. And these two arguments will be used to calculate position of a substring that should be replaced. I will now paste here one comment, and inside of that comment we will see how we can calculate position of a substring to be replaced. First, we will notice that we are replacing everything between positions 3 and 6. So the first value is 3, the last value is 6, and 3 is calculated as second argument plus 1. And 6 is calculated as a summation of second and third argument, so that is how we know what to replace. Now, in this second expression, we are using negative number as a second argument, but the result will still be the same. And this is because in this case, we have a string with 10 letters, and we will count -8 from the end. So we will go -1, -2, -3, -4, and so on. So the result will be like in this comment. So I will paste here one comment. We will have 10 minus 8. So because this is 10, then we go -8. So the result will be 2. And then we will get the same calculation as above. So the result will be the same. If we make this second argument in insert function too big, for example, if the second argument is, for example, 50, in that case, we will just concatenate this first string and the last string. So if we run this, we will just get one big string. Next function is a function that is similar to insert. And this function is only different in this second argument. So with insert function, we should provide value 2 that will be increased by 1. But with this stuff function, we should immediately provide the value 3. So if I run this, I will get the same result as above. Now, if we make a mistake with this stuff function, and if we provide a second argument that is too big or too small, for example, here second argument is negative number, here is a number 50, then we will get results that are empty strings. One interesting thing about this stuff function is that the third argument can be negative. We can see that in this example. Here the third argument is -1, and here is -2. So what will this do? Well, I will run this statement, and first we are searching for the letter on the third position, that is the letter N. And because this third argument is 0, we will not replace anything. We will just break this string into two parts, into re and markable. And between re and markable, we will place mark. So our result will be re, mark is in the middle, and then markable. So that is how this replacement will work. Although we are not replacing anything, we are just inserting this because this third argument is 0. But what if this third argument is -1? In that case, between mark and markable, we will have this letter E. And if the value is -2, then between mark and markable, we will have every. So -1 means that we are repeating this E once more here, and -2 means that re-E from here will be repeated here as a re-E. So that is how this negative argument will affect our function. I will now clear my screen.